Alright, welcome to iChem Lesson 2 on Basic Atomic Structure. For this lesson you will need your viewing guide to take notes, and you should probably have your periodic table given to you in class, especially if you want to follow along with the example questions towards the end. So what does the atom look like? An example from pop culture, I'm pretty sure you've all seen the show Big Bang Theory, or potentially their model of the atom that they use in their opening credits and their logo before. It just kind of depicts a sphere in the center and then these other spheres swirling around. There's some truth to this model, and there's some pieces that this model is missing. So let's sort of build upon this idea and think about what the atom structure is like. So the basic anatomy of that previous model is right. You have the nucleus in the middle. The nucleus, if we dive in a little closer, is made up of protons and neutrons. It's the dense core near the center of the atom. Around the nucleus is the electron cloud. This is a very sparse area. If you remember from class today, we talked about how the nucleus is this dense core, but if we're talking about the overall volume of the atom, the nucleus is so small. Those electrons are far away from each other, relatively, and they're spinning around the nucleus, which is in the center. So we want to look at each of the subatomic particles. We would have the proton, the neutron, and the electron. The proton has a positive charge. It's located in the nucleus and it has a mass of approximately 1 AMU, atomic unit. The neutron has no charge. It's also located in the nucleus with the proton, and it has a mass approximately equal to the proton, so also 1 AMU. The electron, as we know, is outside of the nucleus. Has a negative charge, spins around the nucleus, and for all purposes of this class, you can assume that the mass of an electron is 0. It is much smaller than the mass of a proton or neutron, so it's not really considered to have mass compared to the other two. Some important numbers related to these subatomic particles. First is the atomic number. The atomic number is that number that's displayed, that whole number that's displayed on your periodic table. So the periodic table that you have, you will find it as that whole number right above the symbol. It is equal to the number of protons, which is important. If you know the atomic number, you know how many protons. If you know how many protons, you know the atomic number. In each case, that allows you to identify the atom. So above, you see the atomic number is 3. Even if you didn't have the symbol, you can look on the periodic table, find atomic number 3, and that will always be lithium. The mass number is not displayed on the periodic table. It is equal to the number of protons plus the number of neutrons. So you don't find it on the periodic table. It's protons plus neutrons. We'll do an example of how you find or use that towards the end. The last one is the atomic mass. This is the number that's displayed on the periodic table. On the periodic table that you have, it is under the symbol. It's calculated using the abundance and mass of each isotope of the element. This idea will be in tomorrow night's iChem lesson, so we don't really need to worry too much about this idea right now. So let's focus on the atomic number, mass number, and this next one called charge. So atoms can gain or lose electrons, and when they do, they become ions. So therefore, if we want to define an ion, we would say it's when the number of protons does not equal the number of electrons. The equation for charge then is the number of protons minus the number of electrons. Now let's stop here and look at this equation for a second. We know that protons are positive. We know that electrons are negative. So let's look at what would happen to the charge if we have more protons than electrons. So more protons than electrons, the charge would be a positive number. Positive, negative. If we have more electrons than protons, this number would be bigger. Therefore, using this equation, the charge would be a negative number. Again, we'll have a lot more practice with this. Just become familiar with the equation. The last thing is isotopic notation. It's how we look at how we're given this information. It can take on two forms. This first one is the most informative form of isotopic notation. In the middle here, the big, you'll see the chemical symbol for the element. In this case, we're just calling it X. It can represent any element. The bottom will be the atomic number. Remember, the atomic number is equal to the number of protons, and it's also the number that's found on the periodic table. So in theory, I don't even need to give you this, because if you know the symbol, you can find it on the periodic table, and then you automatically know the atomic number. The mass number is in this notation written in the top left corner, and it's not apparent here because this is not an ion. If this were an ion, you would have a number in the top right corner that would represent charge. There is one more way of looking at atomic notation. It doesn't quite give you as many numbers. Here's an example. So this is the isotope carbon-12. Obviously, you have the name of the element given to you, but what's that other number? That other number is the mass number. So if we compare these two formats, they both give the mass number. This one doesn't outright give you the atomic number, but if you found carbon on the periodic table, you could find the atomic number, which would give you the number of protons. This form does not tell you anything about charge. All right, so let's do two examples. We'll definitely dive more into this in class tomorrow, but two examples. First one, how many protons, neutrons, and electrons are in the sodium atom above? So let's look. We have sodium here. In the bottom corner, we have the atomic number, that's 11. Remember, the number of protons is always the same as the atomic number. This provides the identity of the element. Now, let's look here at the mass number. Remember that mass number is protons plus neutrons. So if I wanted to find the number of neutrons, I would rearrange that equation. Mass number minus atomic number, or number of protons, would give me neutrons. Sorry, this was in the opposite order here. If I wanted to find electrons, I look at the charge. Remember, charge is protons minus electrons. If it's a positive charge, that means there are more protons than electrons. If I plug it into the equation, I would find if I have a +1 charge, I have 11 protons and I have 10 electrons. All right, let's kind of do the opposite here. Now I know how many protons, I know how many neutrons, and I know how many electrons. I want to write the isotopic notation. Remember, the big number in the middle is the symbol for the element. So I'm going to use my number of protons to figure out which element this is. Remember, protons equals atomic number, so I'm going to look on my periodic table and find atomic number 50, which is right here on the left, sort of halfway down. This element is tin with symbol SN, so I'm going to write that there. Protons is the same as atomic number, so I can write that 50 in the bottom corner. Remember, mass number, which goes up here, is protons plus neutrons, so 50 plus 69 is 119. And then lastly, electrons. Charge is protons minus electrons, so 50 minus 48, I get plus 2. I know for some of you, maybe I went through this a little bit fast, I didn't write down all of the equations, and that's because you're going to kind of work through some discovery of these equations and working through them tomorrow. I just want for you to be able to know, look at an isotopic notation and know which number is which. The math and the calculations, although they're easy math, just addition and subtraction, it might take a little bit of getting used to how the numbers all relate to each other. So come prepared to kind of work more with this tomorrow.